So they are sitting at the same place, but I am far away, 30 kilometers from my residence.
So the beginning will just be the introduction of the meeting of the day, yeah?
Yeah, also some awards, which will be a quick affair, but they do take time, you will see.
Yeah, I will be with it at the beginning, and then I will switch out and come back in about 3 hours.
Yeah, maybe 5 to 10 minutes before your lecture time, right?
Yeah, my lecture is at, what is it, 3:40?
3:40 p.m., right, that's right.
40 p.m.
Yeah.
Subsequently, to further strengthen the framework for human resource development at DAE establishments and push the frontiers of nuclear science and engineering through academic programs, the Homi Bhabha National Institute, HBNI, was established in 2005. It was recognized as a deemed to be university by UGC and given the status of a grant-in-aid institution of DAE in 2014. HBNI was accredited with an A grade by National Assessment and Accreditation Council in 2015. HBNI conducts postgraduate and doctoral programs in various disciplines across its 11 campuses, comprising the 4 research and development units of DAE, Bhabha Atomic Research Center, BARC, Mumbai, Indira Gandhi Center for Atomic Research, IGCAR, Kalpakkam, Raja Ramanna Center for Advanced Technology, RRCAT, Indore, and Variable Energy Cyclotron Center, VECC, Kolkata, and the 7 grant-in-aid institutions of DAE, namely Harish Chandra Research Institute, HRI, Prayagraj, Institute of Mathematical Sciences, IMSC, Chennai, Institute of Physics, IOP, Bhubaneswar, the Institute for Plasma Research, IPR, Gandhinagar, National Institute of Science, Education and Research, NISER, Bhubaneswar, Saha Institute of Nuclear Physics, SINP, Kolkata, and Tata Memorial Center, TMC, Mumbai. HBNI is thus a conglomeration of constituent institutions and off-campus center with a thriving academic and research environment. The organizational architecture of HBNI, with a central hub at Mumbai being linked to centers of excellence all around the country, is one of its strengths and has facilitated research and development across diverse disciplines while sharing common objectives. The academic and research activities at the constituent institutions have significantly enhanced the country's indigenous capability in nuclear science and technology, and generated capable and dynamic human resources to man and spearhead these programs. HBNI offers options in 32 diverse academic programs across physical sciences, chemical sciences, engineering sciences, mathematical sciences, life sciences, medical and health sciences, as well as humanities. In addition, HBNI also runs several academic programs towards skill development.
Arunya, we can start.
A very good afternoon to this esteemed chief guest who's joining us from France. respected dignitaries present in the HBNI Council Hall, other dignitaries and attendees joining us on the WebEx virtual space, and audience of the YouTube live stream. My name is Karunya. I'm a PhD student at HBNI and a scientific officer in Food Technology Division, BRC. I'm delighted to be your host for today, and on behalf of Homi Bhabha National Institute, it is my immense pleasure to welcome you all to the HBNI Foundation Day. Before we proceed, I kindly request all attendees to keep the audio muted for the duration of the program. Thank you. Today, we celebrate the HBNI Foundation Day that is observed on 3rd of June every year to mark the day Homi Bhabha National Institute was notified as a deemed to be university by the University Grants Commission. We are privileged to have a highly distinguished chemist as the chief guest today, Professor Jean-Marie Laine. He is a Nobel laureate, the chair of Chemistry of Complex Systems, and director of Laboratory of Supramolecular Chemistry at the University of Strasbourg, France. It is a huge personal honor to have the opportunity to welcome you to this program on behalf of HBNI, sir. Professor Laine will be introduced in detail later on in the program by Professor J.B. Joshi. This program is presided over by Shri K.N. Vyas, Honorable Chairman of Council of Management, HBNI, and Secretary, Department of Atomic Energy. Also joining us are members of Council of Management, Academic Council, Planning and Monitoring Board, Board of Studies, Dean's Academic, other distinguished members from DAE and non-DAE family, faculty and students from all 11 campuses of HBNI. Today's agenda include the conferment of Outstanding Student Awards and Innovation Awards, which will be followed by the J.B. Joshi Research Foundation Endowment Lecture to be delivered by our esteemed chief guest. Before we move on with the agenda, I kindly invite Professor D.K. Maiti to pay tribute on behalf of all of us to the late Professor Srikumar Banerjee, Chancellor HBNI, former Chairman Atomic Energy Commission, and former Secretary, Department of Atomic Energy, who passed away on 23rd of May this year. Sir, please.
It is with a sense of profound grief and shock we record the untimely passing away of Professor Srikumar Banerjee, Chancellor HBNI, in the early hours of 23rd May 2021. Professor Banerjee joined DAE through the 11th batch of BRC Training School and occupied the position of Director BRC in April 2004. He took over as Secretary Department of Atomic Energy and Chairman Atomic Energy Commission on 30th November 2009. He demitted his office on 30th April 2012 after 45 years of distinguished career in DAE. During 2012 to 17, he was DAE Homi Bhabha Chair Professor in BRC. As Director BRC, Professor Banerjee was a member of the Academic Council of HBNI from the very beginning and participated in all discussions towards the evolution of working framework of HBNI. He was the chairman of the Council of Management of HBNI from November 2009 to April 2012. He was appointed as Chancellor HBNI in July 2015, and his tenure as Chancellor was further extended by 5 years with effect from July 2020. As Chairman of Council of Management and subsequently as Chancellor of HBNI, Professor Banerjee played a key role in shaping several academic programs. He always stressed on high quality of doctoral research and also emphasized on interdisciplinary research. He played several academic roles, including Chairman of the Standing Academic Committee and chaired doctoral committees of several students of engineering sciences in BRC. He delivered courses, authored books, mentored students, and thus contributed in every possible manner to the academic activities of HBNI. He also delivered several inspiring lectures to undergraduate aspirants for career in science and engineering research. Professor Banerjee was the recipient of several awards, including the National Metallurgist Day Award in 1981, Santi Saru Bhatnagar Prize in 1989, and Padma Shri in 2005. He was a fellow of all the science and engineering academic in India, as well as the World Academy of Sciences. Several universities and institutes awarded him honorary PhD and DSc degrees and offered him visiting positions. He acted as the chairman board of governors of several institutes of repute. Professor Banerjee was a rare combination of an excellent researcher, able administrator, excellent mentor, and above all, a fine human being with whom everyone enjoyed interacting. His passing away is a great loss for the Indian scientific community in general and HBNI in particular. He will be remembered forever by his students, colleagues, and peers. May his soul rest in peace.
Thank you, Professor Maiti. At this juncture, as a mark of respect to late Professor Banerjee, we kindly request all the participants to stand up and observe 1 minute of silence. Thank you. Now, I kindly invite Professor P.D. Nayak, respected Dean, HBNI, to give the welcome address.
Good afternoon to everyone. For this function, most of the dignitaries and participants have joined online, either on WebEx or on YouTube platform. I extend a hearty welcome to all of you to Homi Bhabha National Institute Foundation Day Function 2021. I welcome respected Professor John Mary Wren, Director, Laboratory of Supramolecular Chemistry, University of Strasbourg, and Chief Guest of today's function. Sir, your presence here this afternoon is a great moral booster to the entire HBNI functionaries. We are glad to have C. K. N. Vyas, Chairman, Council of Management, HBNI, and Secretary, Department of Atomic Energy, is with us. His constant guidance has helped HBNI to attain the present high position among academic institutions. We feel extremely honored with the presence of Dr. R. Sitambaram, former Principal Scientific Advisor, Government of India, Dr. Anil Kakodkar, Member AEC and Chairman, Rajiv Gandhi Science and Technology Commission, Dr. R.K. Sinha, former Chairman, HBNI Council of Management and Secretary, Department of Atomic Energy, Professor J.P. Mittal, Distinguished Professor and Chair, Academic Board, Center for Excellence in Basic Sciences. I welcome you all, sirs. I extend very warm welcome to Professor R.B. Grover, Professor Emeritus, HBNI, and Founder Director, HBNI. Professor J.B. Joshi, Professor Emeritus, HBNI, Dr. J.V. Yakmi, former Associate Director, Physics Group, DARC. Today, heads of various DAE units, vice chancellors, and directors of various universities and institutes in India have joined online. Thank you, sirs, for joining the function. I gladly welcome members of Council of Management, members of Planning and Monitoring Board, members of Academic Council, members of Board of Studies, Dean Academics of various institutions of HBNI, faculty members of HBNI, distinguished faculties and personalities from other institutions, staffs of HBNI Center Office and other DAE units, and students. We are missing today the presence of Professor Srikumar Banerjee, Chancellor HBNI, and Dr. Shekhar Basu, former Chairman HBNI Council of Management. They left only about on May 2021. Srikumar Banerjee left us. In September 2020, we lost our former Chairman HBNI Council of Management and former Secretary Department of Energy, Om Shanti. Higher education institutes are engines of innovations. Many of the high-tech products, which have very high market values and other things, as well as raw tech products, but having very useful society applications, are the result of pioneer work done by university researchers, which includes students. Department of Atomic Energy established the Homi Bhabha National Institutes, HBNI, in 2005 to promote high-quality education and research in nuclear science and technology and to generate talented human resources for societal benefits. In the last 16 years, HBNI has awarded over 1,800 PhDs, and its faculty in association with the students have published on the average over 2,000 high-quality research articles in high-impact journals every year. The students have also contributed to technology development, as evident from being one of the innovators in many of the patents filed by the scientists. HBNI achievement as one of the topmost universities in the country is mainly due to efforts of its 10 constituent institutions and 1 off-campus centers. I would like to thank directors of these institutes, faculty members, students, administration, and other non-teaching staff for their contribution to raising the academic standards of HBNI. Before ending my welcome address, I congratulate all the graduated students of 2021 batch and special congratulations to awardees. Thank you.
Thank you, Professor Nayak. I now invite Professor P.R. Vasudeva Rao, respected Vice Chancellor, HBNI, to deliver his report.
Respected Professor Jean-Marie Len, Chief Guest of today's function, Sri K.N. Vyas, Chairman of the Council of Management of HBNI, Secretary of Department of Atomic Energy and Chairman, Atomic Energy Commission, Dr. Chidambaram, Dr. Anil Kakotkar, Dr. Sinha, Professor Mittal, Professor Grover, Professor Joshi, and other distinguished participants, my dear colleagues, faculty, and dear students and invitees. We have gathered today under the shadow of a very painful event, the passing away of our beloved Chancellor, Professor Srikumar Banerjee, on 23rd last month. Last September, we lost Dr. Shekhar Basu, former chairman of our Council of Management and Secretary DAE. We will take all steps and strive hard to enhance the status of HBNI as a unique university, a mission that was close to their hearts. The last academic year was dominated by the COVID pandemic, and our efforts were mainly focused on devising processes that will ensure minimum inconvenience to our students and faculty, but at the same time, maintain the academic rigor. As compared to 2019-20, when we had awarded 248 PhD degrees, 192 degrees only were awarded in the year 2020-21, which is a reflection of the difficulties encountered by the students in completing their programs. The pandemic at the same time made us learn a new way of life with online meetings, webinars, and courses. I am happy to inform that starting from the Foundation Day program on 3rd June last year, till today, HBNI has organized 27 webinars covering a wide variety of subjects starting from dark energy to quantum computing, and including the celebration of special events such as the 125 years of discovery of radioactivity. More recently, we have also started a series of webinars titled Swasthya Vidya to provide expert advice and education on important medical and health issues to our stakeholders. We also organized 3 special courses online, one on neutron scattering, one on design of multi-phase reactors and contactors, and one on nuclear science and technology. An orientation course on nuclear law and policies is now in progress, and later this month, we are starting a course on advanced materials chemistry. We have also signed an MOU with Indian Institute of Management, Ahmedabad, to organize courses on management aspects for the benefit of senior officers in DI. I must mention here that the encouragement and push given by Professor Banerjee was one of the primary factors behind these efforts. During the last 1 year, we also introduced 4 unique programs, some of them not available in the country. MSc in Nuclear Medicine and Molecular Imaging Technology, MSc in Public Health and Epidemiology, MSc in Occupational Therapy and Oncology, and MSc in Hospital Radiopharmacy. 5 more programs, including MSc in Patient Navigation, are on the anvil. The last year also saw good progress in our efforts to publish unique books. The book on the physics of nuclear reactors was published by Elsevier last month and is formally being released during this function. 2 books, one on nuclear fuel cycle and one on nuclear reactor thermal hydraulics, and also a Hindi glossary of terms related to nuclear science and engineering, are on the anvil. One point I want to emphasize here is that in all these activities which I have described above, we have had the involvement of a significant number of retired DIE professionals in addition to serving experts. The second cycle of accreditation of HBNI by National Assessment and Accreditation Council is underway, and we expect to receive the grade in the coming weeks. The exercise of accreditation provided us a number of lessons for fine-tuning our system. HBNI is making concerted efforts to respond to the requirements of all its stakeholders. For instance, we have started a research scholars forum recently to bring together the research scholars and provide them unique training and other opportunities. My hearty congratulations to the students being conferred with Outstanding Student Awards and Innovation Awards today. I must also record our congratulations to several of our faculty who have won prestigious awards during the last 1 year. And I want to particularly mention Dr. Kinshuk Das Gupta of BRC, who won the Shanti Swarup Bhatnagar Award, and Dr. Bedangadas Mohanty of NICER, who has been elected as the Fellow of the American Physical Society. Before concluding, let me place on record our special thanks to Professor Jean-Marie Len for kindly agreeing to be the chief guest for today's function. Our sincere thanks to the chairman and members of the Council of Management, Academic Council, Planning and Management Board, and other bodies, deans at our CIs and OCC, and my own colleagues at the Central Office for all their contributions that have helped in the progress of HBNI over the years. Thank you very much.
Thank you, sir. As respected Vice Chancellor, HBNI mentioned in his report, on 19th of May this year, Elsevier released the first book coordinated by HBNI Central Office titled Physics of Nuclear Reactors. Dr. Uma Shankari Kannan, Head, Reactor Physics Design Division, who's one of the editors of the book, is present here with us today. We kindly invite her to brief us about this book.
Thank you very much for giving me the opportunity to talk about this book. Respected Chairman, Atomic Energy Commission, Chief Guest of today's Foundation Day, Professor Jean-Marie Len, Vice Chancellor of Homi Bhabha National Institute, Professor Vasudev Rao, Professor J.B. Doshi, Dr. Grover, Dr. Datta, Professor P.D. Nayak, participants from the CIs, ladies and gentlemen, a very, very good afternoon to you. It is indeed a great privilege to be participating in the release of our book, The Physics of Nuclear Reactors, which is a culmination of efforts of many of our colleagues under the coordination of HBNI. On behalf of my co-editors, Dr. Mohan Krishnan and Dr. Rompal Singh, and several contributors, I'm honored to be talking about the salient features and the motivation behind the book. Thank you for giving me this opportunity. It is both a joyous and a momentous occasion for all of us to be a part of this project. We have tried to put whatever knowledge and experience we have gained over the past years. The book is an off-the-shelf and an online comprehensive study material for reactor designers and practicing reactor physicists. What was our motivation? Reactor physics has been an essential part of the manpower development in DAE. When we were engaged in teaching, we found that we are referring to different books for basic reactor physics, the linkages to the reactor engineering, operation, experimentation, fuel cycle, and shielding. Also, the nuclear energy program, as it matures, there are several multidisciplinary aspects in which we are required to gain knowledge. So we sat down and carefully planned the chapters. The book has evolved out of the vast experience of about 60 years of our peers and our colleagues, and a collective thousands of man-hours of introducing this subject as part of the training school curriculum. In the last decade, a dedicated nuclear reactor physics course was also added as another stream by DAE to generate expertise in this specialized subject and contribute to the nuclear program more effectively. There are 12 chapters in this book, totaling to about 767 pages. The subject has been gradually developed from nuclear physics, nuclear data, methods of solving neutron transport equation, to fuel management, fuel cycle physics, reactor kinetics, regulatory and operational reactor physics, experimentation, and shielding. Safety analysis, both deterministic and probabilistic, is covered in a chapter. Reactor experimentation and description of the critical facilities is also detailed in a separate chapter. The book also includes a chapter on advanced reactor systems, fusion and accelerators from a reactor physics point of view, and a brief on the 3 major accidents: safety, safety principles, and safety guidelines. HBNI has coordinated this huge effort in bringing together the contributors, reviewers, and the publisher. Publishing a book is very much different from publishing a paper. We are thankful to Dr. Rao for his constant guidance and encouragement. It was an enriching experience for us and also a steep learning curve in interlinking the various fields. We miss Dr. Banerjee, Chancellor HBNI today. He had written a very stimulating foreword for the book. We are also thankful to all the reviewers who have toiled along with us to enrich the technical content. Thank you, one and all. I now request Chairman to release the book. Thank you, sir.
Thank you, Dr. Kannan. Now, I kindly request Honorable Chairman, Council of Management, HBNI, Shri K.N. Vyas, to deliver the presidential address.
Thank you very much, Karunya. Good afternoon to one and all who have gathered to celebrate the Foundation Day of HBNI. I would like to add my words of special welcome to the respected chief guest of today's function, Professor Jean-Marie Laine, Director, Laboratory of Supramolecular Chemistry, University of Strasbourg. Sir, we are honored by your participation in today's program. I am very happy that Dr. R. Chidambaram, Dr. Anil Kakotkar, Dr. R. K. Sinha, Professor J. P. Mittal, Professor R. B. Grover, Professor J. V. Joshi, Dr. J. V. Yakmi, Vice Chancellors and Directors of various universities and institutes in India have joined us on this occasion. We are indeed honored by your presence here. I convey my greetings to Vice Chancellor, Deans and other members of HBNI family, and also to the heads of various DA units, members of Council of Management, members of Planning and Monitoring Board who have joined on this occasion. We are today celebrating the Foundation Day of HBNI And on this occasion, I extend my greetings to the students, faculty, academicians, functionaries, and all other involved in this very unique and one of its kind institutes in the country. In a journey spanning 16 years since its inception, HBNI has overcome many challenges, many great strides, and chalked up numerous achievements and milestones. The Foundation Day is an occasion to look back and celebrate these achievements and milestones, reaffirm our objectives and commitments, and set a roadmap for the future. Before I begin, I would like to express my deep sense of sorrow at the sudden and unexpected demise of Chancellor HBNI, Dr. Srikumar Banerjee, some days back. He was a great scholar, scientist, academician, and an administrator, and had been associated with HBNI in various capacities from an early stage, making immense contributions towards its growth and emergence as one of the reputed institutes of higher education in the country. Prior to that, about a year back, we had lost Dr. Sekhar Basu, another luminary and leader actively associated with HBNI. Dr. Basu steadfastly supported and steered the institute with his leadership, mentorship, and guidance. We deeply mourn these losses. The year gone by has been one of the most difficult years, with the country having suffered 2 waves of COVID-19 pandemic. The second wave is still ongoing and has caused tremendous suffering and losses. We have faced prolonged lockdowns and cessation of normal activities over this period. However, it is heartening to note that HBNI has continued to function and has delivered on its commitments despite being hampered by the pandemic. It is creditable that all the academic programs scheduled during this period were conducted and completed successfully. Enormous efforts were taken by the faculty and support staff, and they are deserving of high praise for their sincerity and dedication. In view of the limitation in holding in-person lectures, several online courses were designed and delivered at short notice to meet the timelines. HBNI has been one of the few universities to conduct exams and declare results within the academic year. Equally noteworthy have been the initiatives taken to introduce several value-added as well as advanced courses during this period, including 4 skill-based oncology courses. Webinars by eminent academicians and experts added to the vibrancy of the academic activities. The research activities of HBNI encompass a wide range of domains, and the outcomes lead to furthering the frontiers of knowledge in reactor technologies, lasers, accelerators, robotics, health physics, fuel recycling, waste management, and many other associated disciplines. The applications of radiation technology in the fields of agriculture, healthcare, food preservation, etc. are also topics of active research at HBNI. The constituent institutions, with their thrust on cutting-edge basic and applied research, have widened and deepened our knowledge in multiple areas of research, adding diversity to our research profile and providing crucial inputs in support of our programs. A great indication of the research strength of HBNI is the fact that more than 2,200 publications have been published in high-impact journals, in addition to numerous patents as co-inventors being filed during the period. Our chief guest, Professor Len, shall confer Outstanding Students Award upon the best performance of academic year 2020, and Professor J.B. Joshi Research Foundation Innovation Award to the best innovative researchers during the year 2019 and 2020. My heartiest congratulations to all the awardees, as well as the guides and mentors for being bestowed this coveted award. I am happy that HBNI Central Office has started contributing to the academic world by publishing book. The first book on HBNI Central Office was released just a few minutes back. I am also happy to note that a Hindi glossary of technical terms in nuclear science and engineering is ready and due to be published. I compliment the authors and editors. Vast information is available these days at the click of a mouse. However, I have learned over the years that there is a dearth of good books in various aspects of nuclear sciences and engineering, especially for the benefit of young students and researchers. I hope that HBNI will be able to fill this gap over the years to come. The foundations for a vibrant, dynamic, and high-quality education and research institute have been laid by our founders and predecessors over the last 16 years, and it is important to look ahead and plan for the future. I would like to share some thoughts on these aspects. Modern day science and technology education and research requires the integration of knowledge and information across multiple disciplines to be able to make meaningful and path-breaking contributions. HBNI is in a position to formulate uniquely blended cross-disciplinary courses, keeping in tune with the requirements of the times, something which cannot be easily offered by conventional university systems. The educational reach of HBNI can be considerably enhanced by offering online courses on our fields of expertise. Though online courses are widely offered on various platforms, there are very few courses available in some of the high-tech areas in which we specialize. This gap can be bridged by our university. The courses could be designed to impart online theoretical education by the learned faculty, supplemented by comprehensive hands-on e-training on state-of-the-art techniques using the power of widely growing virtual and augmented reality platforms, thus thereby creating a seamless real-life experience. Exposures and hands-on experience on important research tools such as programming and numeric computing platforms, simulation software, etc. should also be extensively integrated into our academic programs. The students graduating from HBNI would thus be not only gaining excellent knowledge in the chosen research area, but also acquire proficiency in multiple skill sets, adding enormously to their value in career openings as well as growth opportunities. As I end, I once again congratulate all the awardees and achievers. And as I end, I am reminded of a quote from Louis Pasteur, the pioneer in vaccine research, and I quote, "Let me tell you the secret that has led me to my goal. My strength lies solely in my tenacity," unquote. Indeed, all students have potential to rise to be the best, provided they have the determination, dedication, willpower, and tenacity to excel and make a meaningful contribution. At the end, I would like to take this opportunity to urge all students and others to follow the necessary protocols to remain safe and healthy, as we are still in the midst of a pandemic and the virus remains to be defeated. Thank you. Jai Hind.
Thank you very much, sir. We now move on to the distribution of awards. There are two types of awards being conferred to the students today, namely the Outstanding Student Awards and the J.B. Joshi Research Foundation Innovation Awards. First, I humbly invite Professor B.K. Datta, Chairman of the Selection Committee for Outstanding Student Awards, to brief us about the selection process and oversee the award distribution.
Thank you, Ms. Karunya. Good afternoon. First of all, let me also welcome all the distinguished attendees, HBNI authorities, HBNI staff, dear students, to the Foundation Day function of HBNI. Of course, we miss Dr. Banerjee. They just say that every good thing has to come to an end. So we have to follow. He decides and we follow. Anyway, as you know, one of the important events of Foundation Day celebration function is to bestow awards to the students who completed academic programs successfully in a particular calendar year with outstanding performances. The awards which are given to the students in the various academic programs are in three categories. Category 1 is the PhD, which also includes integrated PhD in the discipline physical sciences, chemical sciences, life sciences, engineering sciences, mathematical sciences, medical and health sciences. Category 2 is the super specialty programs in medical and health sciences, namely DM and MCH, that is Doctorate of Medicine and Master of Chirurgy. And third category is the postgraduate programs, which are namely MSc Engineering, MTech, and MD. Now, the evaluation criteria are stringent and a long-drawn process involving various levels of authorities. For example, doctoral students are evaluated based on their performances in coursework, oral journal comprehensive exam, gradings given by a doctoral committee during annual review, completion time of the thesis, number of publications and corresponding journal impact factors, quality of the research work, reviewers' comments on the thesis, contributions towards the development of new theory, product, facilities, relevance of research work with respect to DI programs, and societal impact. Similar applicable criteria are chosen for other PG level programs and super specialty programs. A student can be nominated either of them by guide, any doctoral committee member, any board of study member, dean or director of the CI. All applications are initially scrutinized in the central office to check their validity. All applications which meet the norms are then sent to Board of Studies discipline-wise for recommendations. The recommended names are then submitted to HBNI Academic Council for approval. And the award consists of certificate, medal, and cash award. Now it is my great pleasure to call upon the names of the awardees who completed their academic programs during the calendar year 2020, that is January 2020 to December 2020. Now there are 17 awardees in this year. The awardees are from different CIs, and the CIs, as you know, are geographically located in different parts of India. Due to prevailing situation and travel restrictions, it has not been possible for the awardees to travel to the present venue here to receive the award in person. However, the awardees who are primarily located in Mumbai have the opportunity to attend this function physically. I'm happy to announce that 5 such awardees are physically present today to receive the awards. I will now call upon their names and request them to receive the awards from Mr. K.N. Vyas, Secretary, Department of Atomic Energy and Chairman, Council of Management, HBNI. May I now request Mr. Vyas to do the honor, please. The first awardee who will be receiving the award in person is Dr. Mayur Ramesh Darekar. He has done PhD in Engineering Sciences, BARC, and his thesis title is Liquid-Liquid Two-Phase Flow and Mass Transfer in Microchannels. Dr. Darekar. Okay. The next awardee is Dr. Ravi Kiran Akela. He has done PhD in Engineering Sciences BARC, and his thesis title is Risk-Based Seismic Performance Assessment of Pressurized Piping Systems Considering Ratcheting. Dr. Akela. Now the next awardee is Dr. Dhiman Chakravarti. He has done PhD in Life Sciences, BARC, and thesis title is Physiological and Structural Characterization of a Manganese Catalyst. Dr. Chakravarti. Fourth awardee who will be taking the award in person is Dr. George Abram. He has done super specialty program in Doctorate of Medicine, that's a DM from TMC. And his specialization is medical oncology. The fifth awardee who is taking the award in person is Dr. Manikandan MV. He has done the PG program in Doctor of Medicine, that is MD from TMC, and his specialization is nuclear medicine. Dr. Manikandan. Mr. Vyas. Thank you. Now we move on to confer the awards virtually to remaining students. The awards are deemed to be presented by today's chief guest. The first academic program is the PhD Physical Sciences. There were 90 students who completed the program, PhD program in 2020 calendar year. 5 have been selected for the awards. And their names are Dr. Ananya Kundu, BARC, and the thesis title is Study of Electric Multipole Transition Probabilities and Their Importance in Reaction Dynamics, Dr. Kundu.
A very good afternoon to everyone. I'm extremely thankful to HPNI for recognizing my work and considering me as one of the outstanding doctoral students this year. Several people have been directly or indirectly involved in the accomplishment of this enormous task that I undertook nearly 6 years ago. Foremost, I express my sincere gratitude towards my thesis supervisor, Dr. S. Chatra from NPD BARC, for his meticulous guidance and steady encouragement over the course of my work, which has really helped in building my knowledge and skills. My special word of thanks go to Dr. Swaminathan Kailash for actively being involved in the progress of my work over the years. My doctoral committee members who have been very generous with their motivation as well as constructive feedback, and also my seniors and collaborators, discussions with whom have immensely helped me build my knowledge on the subject. I am profoundly grateful to Almighty God for gracing me with opportunities, my parents for their countless blessings, and I hope I've made them proud. Thank you.
Thank you, Dr. Kundu, and congratulations. The second awardee in PhD Physical Sciences is Dr. Raktima Basu from IGCAR, and the thesis title, Mechanism of Phase Transition in Vanadium Oxide and Its Applications, Dr. Raktima Basu. Okay, now we go to the next awardee in the area of PhD Physical Sciences, Dr. Subhamay Haldar from RRCAT. And the thesis title is Magneto-Optical Transport Studies on Ultra-Low Disordered Semiconductor Quantum Wells Grown by MOVPE. Dr. Subhamay Haldar, please.
Hello everyone, I am Shubhamay Haldar. I did my PhD from Raja Ramanna Center for Advanced Technology Indore under the Homi Bhabha National Institute PhD program. So first of all, I'd like to thank HBNI Mumbai for providing me the research fellowship and giving me this opportunity to work in such a good research environment. Thank you. It was really a great journey. I'd also like to acknowledge all the selection committee members who chooses me to provide this outstanding doctoral student award. It really feels nice and appreciated and motivates me to do something better in the future. I'd like to dedicate this award to my supervisor, Dr. Vijay Kumar Dikshit, and my parents. Thank you.
Thank you, Dr. Haldar, and congratulations. Now, fourth awardee in the area of PhD Physical Sciences, is Dr. Soumik Bhattacharya from VECC, and the thesis title, Erased and Near Erased Structure of Nuclei in A200 region involving high J orbital, Dr. Soumik Bhattacharya. Okay. Now the fifth and last awardee in PhD Physical Sciences is Dr. Avik Banerjee from SINP, and his thesis title, Aspects of ADS/CFT with Fundamental Flavors. Dr. Avik Banerjee from SINP. Okay. Now we move on to the next academic program and discipline, that is PhD in Chemical Sciences. There were 33 students who completed the PhD in 2020 in the area of chemical sciences, and 2 have been selected for the awards. And they are Dr. Santosh L. Gawali from BARC, and the thesis title is Interfacial Modifications of Nanomaterials for Biomedical Applications. Dr. Santosh L. Gawali.
Good afternoon, everyone. Thank you very much, sirs, for selecting me for this award. It is really an honor for me to receive this from HBNI. This will be an excellent moral booster for me and will surely encourage me to do good work in the coming years. I would like to thank HBNI for providing me an excellent platform to carry out my research work, which lead to enormous learning opportunity. And also big thanks goes to the BRC for providing me all facility with a clean work environment that lends itself to creativity and productivity. This is one of the most significant events in my professional career. Thank you once again for this great honor. Thank you.
Thank you, Dr. Gawali, and congratulations. Now, the second awardee in PhD Chemical Sciences is Dr. S. Tyagarajan from NICER, and his thesis title is Catalysis Based on Ruthenium Pincer Complexes. Dr. S. Tyagarajan.
Hi, this is Tyagarajan. I have completed PhD from NICER Bhubaneswar in 2020. Thank you very much, HBNI and the committee people, to selecting my name for the Outstanding Doctoral Student Award for the year of 2021. My title of the PhD is Catalysis Based on Ruthenium Pincer Complexes. Using Ruthenium Pincer Complexes, we have developed several green and sustainable catalytic transformation in our laboratory. My sincere thanks to doctoral supervisor, Dr. C. Gununathan, for his valuable guidance and sincere and suggestions. And my sincere thanks to School of Chemical Sciences, NICER and HBNI to providing the infrastructure and instrument facility to carry out my research. Finally, I will thank to UGC to providing fellowship to continue my research. Thank you.
Thank you, Dr. Tyagarajan, for your words, and congratulations. Now we move on to PhD in Engineering Sciences. There were 27 students who completed PhD in 2020 in the area of engineering sciences. 3 have been picked up for the awards. Out of 3, Dr. Darekar and Dr. Akela, both from BARC, already received the awards in person from Mr. Vyas. And the third award is Dr. Preeti Kant from IPR. And the thesis title is Nuclear Activation Studies in Fusion Systems, New Methods and Algorithms, Dr. Preeti Kant.
Thank you, everyone. I'm extremely grateful to receive this honor. Firstly, I want to thank my PhD supervisor, Dr. P.V. Subhash, for all his guidance and motivation. I also want to thank my co-supervisor, Dr. R. Srinivasan, who is sadly no longer with us. He was always very helpful and kind to me. I want to thank my doctoral committee members, Professor Shishir Deshpande, Dr. Manik Bandyopadhyay, and Dr. Vinay Kumar, for their support and encouragement throughout my PhD. Last but not the least, I want to thank my colleagues, my family, and my friends for always being there for me. Thank you.
Thank you, Dr. Kant. Congratulations again. Now we move on to the PhD in Life Sciences. There were 26 students who completed PhD in Life Sciences in the calendar year 2020. Two have been picked up for this Outstanding Student Award. Out of that, Dr. Dhiman Chakravarti has already received the awards in person. And the second award is Dr. Rathod Maitri Amit from TMC. And the thesis title, Identifying Mechanisms that Regulate Humans' Sodium Iodide Supporter gene expression in breast cancer. Dr. Maitri Rathod.
Good afternoon. It is a great honor to receive the HPNI Outstanding Doctoral Student of the Year Award. Thank you, HPNI, Dean HPNI, and award committee members. I would like to thank the Chief Guest, Professor Jean Mary Len, for presenting this award. A sincere vote of thanks to my guide, Dr. Abhijit Day, who has obviously played the most important role behind this award. Thank you, sir, for bringing out the best in me. I am grateful to Director Attrick, Deputy Director Attrick, for providing a stimulating scientific environment, infrastructure, and support. I would like to thank my doctoral committee members and Dr. Preeta Ray for their role in my academic progress. Thank you, family, friends, and lab members for being a constant support. I would like to end on a note saying that this award has certainly boosted my motivation to do better as a researcher in future endeavors. Thank you, everyone.
Thank you, Dr. Rathod, and congratulations. Now we move on to the DM and MCH award. These are the super specialty award in the area of Doctorate of Medicine and Master of Chirurgy. And there were two awardees. Out of that first awardee, Dr. George Abraham already received the awards in person. And the second awardee is Dr. Sravan Nadkarni, MCH TMC. And his specialization is surgical oncology. Dr. Sravan Nadkarni, please.
Hello everyone, I am Dr. Sravan Nadkarni, completing my specialization in surgical oncology, which is in fact the surgical treatment of solid organ cancers from the prestigious Tata Memorial Hospital, Mumbai. I feel truly humbled and honored for having been conferred the Outstanding Student Award by the Homi Bhabha National Institute. This recognition is in fact a testament to the discipline and rigorous training that residents go through in one of the finest and possibly one of the largest cancer centers in this part of the world. I wish to express my gratitude to my teachers, colleagues, seniors who have inspired me, helped me, and encouraged me. My dearest parents, Dr. Sharad and Dr. Vijay Nadkarni, who have taught me the importance of hard work with integrity and continue to do so in their 45-year-long medical career, especially during these times of need. My wife, Dr. Apurva Ayachit, a vitreoretinal surgeon, has been rock solid and my pillar of strength, taking care of our beautiful little toddler, Kaushiki. My parents-in-law, Dr. Guru Prasad Ayachit and Mrs. Shamala Guru Prasad, for their unwavering support and encouragement. Last but not the least, our patients at Tata Memorial who travel far and wide in search of quality cancer care. This honor will surely spur me on in my quest for delivering quality cancer care with the guiding principles of service, research, and education that our hospital stands for. I thank you for this honor.
Thank you, Dr. Nadkarni. Congratulations again. Now we move on to the last category of award, that is MD. There were 81 students who completed the MD program in 2020. 3 have been picked up for the Outstanding Student Awards. The first awardee, Dr. Manikandan, has already received the awards in person from Mr. Vyas. Now the other 2 awardees are Dr. Anurag Gupta from TMC, and specialization is radio diagnosis. Dr. Anurag Gupta.
Good afternoon, everyone. I am truly humbled to receive this singular honor. I would like to dedicate these awards to my parents for all the hard work and sacrifices they have made. I would like to thank all of my respected mentors, my wonderful seniors, all of the batchmates, juniors, and friends who have always believed in me. And I don't think I can thank you all enough with all of my words. And of course, my dear alma mater Tata Memorial Hospital for instilling all the core values and principles. Please accept my endless gratitude. Thanks a lot.
Thank you, Dr. Anurag Gupta. Congratulations. And now the third awardee in MD category is Dr. Pratibha Tyagarajan from TMC, and specialization is anesthesiology. Dr. Pratibha Tyagarajan.
Hello everyone, I am Dr. Pratibha from the Department of Anesthesiology. I am from Tamil Nadu. There's an old saying in Tamil, Yadum Ure Yavarum Kelir, which means every place is my own and all people are my own kinsmen. And this is exactly how I felt here in our Tata Memorial Center. My heartfelt thanks to each and every one of you who made this place feel like a second sweet home to me. My sincere thanks to the HBNI and TMH for providing me with endless opportunities and a great environment to learn. A special thanks to my guide Dr. J.V. Divatya sir and my co-guide Dr. Raghu Tota sir for helping me throughout this challenging journey. I would also like to thank my colleagues, my friends and my lovely family who are there for me anytime. We all have been relentlessly working as frontline warriors in this pandemic.
Okay. So thank you, Dr. Tyagarajan, and congratulations. So congratulations to all the awardees. And with this, we come to the end of the Outstanding Students Award function. Thank you all. Over to Ms. Karunya. Thank you.
Thank you, Professor Datta. I now invite Professor P.D. Nayak, respected Dean HBNI and Chairman of the Selection Committee for the Innovation Awards, to take over the award distribution for the J.B. Joshi Research Foundation Innovation Awards.
Thank you, Karunya. I am in front of you to announce J.B. Joshi Research Foundation Innovation Awards. J.B. Joshi Research Foundations donated rupees 19 lakhs to HBNI to establish J.B. Joshi Research Foundation Endowment Fund. The interest obtained from this fund is utilized for organizing the J.B. Joshi Research Foundation Endowment Lecture and Innovation Awards to HBNI PhD students. This year, a nomination has been invited from HBNI PhD students graduated in the year 2019 and 2020. More than 450 students were eligible for the award, and HBNI received 11 nominations. A committee was constituted by J.B. Joshi Endowment Committee for evaluating the nominations. The committee shortlisted 6 nominations for presentation of the work based on the parameters with weightages. The selection process is a two-tier process. One is the shortlisting and then presentation by the students to tell to the committee that the novelty of his innovations. In shortlisting was based on the various parameters with weightage. I'm going to read out that. One is the degree of innovations, that is the novelty of idea or creativity of the concept with a weightage of 30%. Second parameter was impact of innovations, that is expected tangible benefits to the departments or society. Again, this was carrying the weightage of 30%. Third one is practicality of innovations in terms of commercial applications or commercial product development with the weightage of 30%, and remaining 10% were given to the publication patent resulted from the innovations. The committee selected 2 students out of these 6 who have been shortlisted based on these above parameters, and this was based on the presentations where students were scrutinized and been asked the questions to prove the novelty of innovations and its likely impact on the development of new product for the DAE mission program or societal applications. I am happy to announce the names of the awardees. These awards are being virtually conferred by our chief guest today, Professor Lan. In the engineering science, the award goes to Dr. Srikumar Tarpara for his innovative work on real-time ultrasonic weaving of immersive structures and components. This innovations as applications for
Namaste. Myself, Dr.
These innovations as applications for core mapping of sodium-cooled fast breeder reactors apart from other applications. Dr. Srikumar, please.
Joshi Research Foundation Innovation Award 2021 for my PhD thesis work. This work is without a doubt the most rewarding project I have ever undertaken. It is also the most fulfilling and one I could not complete it alone. I have been intensely blessed to have great teachers, mentors, friends, and family to encourage me. And I am also grateful for their generosity in sharing their knowledge and their consistent support. My special thanks goes to my PhD guide, Dr. V.S. Patankar sir, my technology advisor, Dr. Kalol Roy sir, Sri N. Vision Warrior sir, my doctor committee, DC5 chairman, Dr. A.P. Tiwari sir, and members, Anup sir and Kar sir. I am also thankful to head ED, other ED staffs, my junior, Harshit and Pawan, HBNI Dean, as well as Chief Guest Professor Jean Maryland. Last but not least, I would also like to thank my parents, my wife Ankita, and all other amazing and admiring people. I am lucky to have all of you. Thank you very much.
Thank you, Dr. Srikumar, and congratulations for excellent work. I also like to thank Professor V.S. Patankar, BARC, for the excellent mentoring. The next award is in basic sciences. The award goes to Dr. Shalini Dimli for her innovative work on rate-based state-3 phosphoryzation of sensors. The sensor demonstrates superior sensitivity, specificity, and excellent eye throughput capability as a potential drug screening tool. Dr. Shalini Dimli, please.
Good afternoon, everyone. I'm feeling extremely honored to be receiving the J.B. Joshi Endowment Innovation Award. And for this, I would like to extend my humble gratitude towards HBNI and the selection committee for giving me this opportunity to present my work and even considering my work for this prestigious award. This definitely would not have been possible without the guidance, thoughtfulness and innovative vision of my PhD mentor, Dr. Abhijit Dey. He always encouraged me to work hard and ask fundamental research questions that made this innovation possible. I would also like to acknowledge Director ACTRAC, Dr. Sudeep Gupta, Dr. Prasanna Venkatraman, Deputy Director ACTRAC, and ex-directors of ACTRAC, Dr. S.V. Chiplunkar and Dr. Rajiv Sareen, for providing us with all the basic infrastructure and a wonderful scientific environment in the ACTRAC. I am equally grateful to my doctoral committee members, Dr. S.V. Chiplunkar, Dr. Prasanna Venkatraman, Dr. Sudeep Gupta and Dr. Sanjay Gupta for always being very critical about my work and giving me fruitful suggestions that really helped me to shape my research work. This achievement has really encouraged me and inspired me to do even better in my future scientific career. Thank you so much for this award.
Thank you, Shalini Dimli, and congratulations. And thanks also goes to Professor Abhijit Dey, ACTRAC TMC, for the excellent mentoring. Finally, thanks to everyone for their patience in the award conferment programs of today's functions. Thank you.
Thank you, Professor P.D. Nayak. We are running ahead of time, so we would like to take this opportunity to view a small video clip of Professor Banerjee speaking a few words about HBNI.
Endeavor and succeed in the fulfilling pursuit of scientific and technical advancements across a gamut of domains.
Education has been an integral part of the department's activity right from the beginning. 4 years back, and is still running very strong. And this is the world's longest nuclear science and engineering education program. It can also claim that the entire technology development indigenously done in the country has come out from the work of those who have been graduated from this training school of the Bhabha Atomic Research Center. So HBNI is a natural extension of this program. Those who have been working in the department for an extended period, sometimes even their entire career, they are having that experience of seeing that their own work, their own research is getting translated into the technology development in a very massive way. This is a very great feeling at the end of the career of many of the scientists who have gone through this within the department. Now that experience can as well be, at least the taste of that experience can as well be given to the students who are coming from outside to the department for their doctoral work. And that is one thing which HBNI can claim to give, and which I believe no other institutions in the country, no other universities in the country can provide.
Let's resume. I now invite Professor J.B. Joshi, former Director of Institute of Chemical Technology, Mumbai, and former Professor Emeritus HBNI, to introduce esteemed chief guest to the audience and invite him to deliver the J.B. Joshi Research Foundation Endowment Lecture. Sir, please.
Today's esteemed chief guest, Professor Jean Marie Lane, Honorable Chairman Shri Vyas, Honorable Vice Chancellor Professor Vasudev Rao, respected Dr. Chidambaram, Dr. Kakodkar, Dr. Sinha, my distinguished friends sitting here, Dr. Grover, Dr. Nayak, Dr. Datta, and many more who are online, and my dear friends. It is my pride privilege to introduce Professor Jean Marie Lane, who is an eminent French chemist and a Nobel laureate. He is presently a professor at the University of Strasbourg, Institute of Advanced Studies, and chairman of chemistry of complex systems. He was awarded the Nobel Prize in Chemistry in 1987 for his studies on the chemical basis of molecular recognition. Professor Jean Marie Lane was born on 30th September 1939 in Rochem, France. He studied at the University of Strasbourg, where he obtained his PhD with a thesis on triterpenes under the guidance of Professor Guy Orison in 1963. He carried out a postdoctoral research at Harvard University with legendary Professor Robert Woodward, Nobel Prize laureate in 1969, working on vitamin B12. Since 1970, he has been professor at the University of Strasbourg, and from 1979 till 2010 at the College of de France, Department of Molecular Interactions. Professor Lane founded the Institute of Supramolecular Science and Engineering in Strasbourg in 2002. He has been involved in a large number of public and private boards and committees, and also participated in several startup companies. As president of the Non-Governmental International Organization for Chemical Sciences in Development, he aims, together with a group of dedicated colleagues, to contribute to helping chemists in developing countries. and we, India, is indeed benefited. He is the author of more than 1,000 scientific publications and 3 books, and member of many academies and institutions. He has received numerous international awards and honors. Among them are Officer of the French National Order of Merit in 1993, Grand Officer of the French Legion of Honor 2014, Austrian Decoration for Science and Art, First Class 2001, Knight Commander's Cross of the Order of Merit of the Federal Republic of Germany 2009, and was conferred the Order of the Rising Sun, Gold and Silver Star by the government of Japan. I'm indeed honored to introduce Professor John Mary Lane. I'm supposed to say something about J.B. Joshi Research Foundation that I will explain in about few minutes. All of us know that prosperity of any nation depends upon the innovative capability of that nation. And just now the introduction to Professor John Mary Lane, it emphasized the same point that not only he does the basic science, but also involved in startup companies for improving the innovative ability of young minds. So the foundation was started in 2015 with exactly the same aim, that is, choose some societal problems which are of importance to the common man, and when the solution is implemented, the local per capita income improves. That is the overall objective. But one hidden objective is this problem should be solved by young minds, boys and girls, and in the process, they become capable of identifying societal problems and solving them and implementing the solution in the society. So that is the overall brief description of the foundation. Another goal together with Marathi Vignan Parishad is for improving scientific temper of the society, and there are about 80 programs which are continuously run throughout the state for improving the scientific temper. Several programs have been taken. One is, of course, the improvement of cook stoves. We know that 3 billion population still uses biomass-based cook stoves, where efficiency is in the range of 12 to 15%. And in the kitchen, there is a huge pollution, and about 16 million women and young children die because of the respiratory problems. This problem was taken by overlapping 5 students and starting from about 16% efficiency using computational fluid dynamics and other modeling tools, as well as instrumentation, and improving the hardware. Several generations of cook stoves have been made, right from 16% to 24% to 28% to 32%, and now the most recent one gives 48%. That 48%, when implemented, it will generate 80,000 crores, if only in India, by saving of energy. The order of magnitude, let us understand, if we take profit of entire chemical industry in India, it is not 80,000 crores. a single problem which has a societal importance and the health improvement plus a lot of health benefits. The second problem which has been solved is the pyrolysis. The nation has a lot of agricultural waste, the solid waste. About extra waste is about 350 million tons. And it is a problem. The present way of taking care is this is burnt in the fields and creates a lot of pollution in adjoining village areas as well as urban areas. And in the months of October, November, and December, we face this problem. So a systematic development of new technology, which is economical, has been developed. The principal objective in all these technologies, two of them I told you. The third most important is if the biomass, extra biomass, is owned by farmers, the benefit should go to the farmers. Right now, the best cash crop is sugarcane, and which gives about 1.75 lakh per acre on an average. And this method of pyrolysis, whatever is waste biomass out of that acre, can give 3 lakh of rupees. And if implemented throughout India, it will create about 20 million jobs, extra jobs, and improve the per capita income of the local community by a factor of 2. So much wealth generation is there. We are then, in addition to cook stoves, the cookers and the whatever vessels that we use on biomass cook stoves, that needed optimization. That efficiency is typically 30% and has been improved to about 70%. There are many places which are waiting for the end of the pandemic. The solar energy, the most important point for implementation, as we know, is the capital cost. And US National Academy of Engineering, they have given an objective that if the total cost of solar thermal is brought down to less than $75 per meter square, then it will get implemented. And I'm pleased to tell you that the students, our students who were supported on J.B. Joshi Research Foundation, in all these problems, there are about 15 PhD students. And I again repeat, the problems they solve is definitely important for the society. But as a teacher, I'm very happy that these innovative abilities and many other abilities of talking to common man and implementing the technology in the society, that abilities they are getting as a teacher, I'm more happy because of these actions which are happening automatically through this program. In solar energy, as I told you, we have been able to reach that mark of $75. And our Honorable Chairman, Shri Vyas, he has encouraged the foundation to transfer that knowledge and make more developments together with BRC. So not only we are going to stop at this development of $75, but bring in many more angles of innovative steam engine, as well as air conditioning and space heating. We need space heating in Himalayan homes, as well as we need air conditioning and, of course, electricity. So that will happen. During this pandemic, J.B. Joshi Research Foundation, they participated in the scale-up of vaccine manufacture. Whatever is the scale, we need to do it efficiently and reliably. So, and the making of pure oxygen. For a single person, it was the technology was developed about a year back, and the capacity of 5,000 units per month has been already executed. And PMO's office, they have also ordered about 5,000 per month. So then we decided about a couple of months back to scale it up. That is for 50 persons at a time, that is on the hospital range, and 100 persons and 1,000 persons. And we are in the process of scaling up those oxygen units. The cashew nut fruits and jackfruits, about 5 million tons of these fruits are thrown on West Coast and East Coast. And the nutraceutical and functional food values in these fruits is very high. We can get approximately 70 to 80 rupees per kilogram of these fruits with the help of value addition. And 2 PhD students have started working on this. There are in cashew nuts, there is a vitamin B, dietary fibers are there, then antioxidants are there. So all these are being isolated in the marketable form. The process of pyrolysis gives, let it be agricultural biomass or let it be the urban waste. The urban waste typically has 30% organic mass. And when pyrolyzed, we get gas, liquid, and solid product. Liquid has many, many valuable chemicals like phenols and chrysols, and all those can be sold at much higher price. The most important product is the solid product, that is char, and char has good interfacial area and porosity, and it can retain the macronutrients as well as water. And we have taken 3 PhD programs for the improvement of fertility of land for soybean. And mainly because why soybean? We import these seeds worth 72,000 crores from outside. And when we increase the capacity by 50% in India, then the problem is going to get solved. And we have shown that using this biochar together with some protocols, the details of which I will tell some other time, we have been able to increase between 85% and 25%. That is, the land which was already fertile, we could increase by 25%, which was unfertile totally, we could increase by 85%, and some of the cases by 300%. There are many, many other programs taken by J.B. Joshi Research Foundation. One of them, as you heard a few minutes ago, is the award of J.B. Joshi Research Foundation Innovation Awards. We wish to institute these awards in many more universities so that the culture of innovation in the country will improve and our nation will become prosper. Thank you very much.
Thank you, sir. I now kindly request our esteemed chief guest, Professor Jean-Marie Len, to kindly deliver his lecture. Yeah, I request our esteemed chief guest, Professor Len, to kindly deliver his lecture. We apologize for the technical glitch, but kindly be patient with us and it will be resolved shortly.
Yes, we can hear you.
Okay, because something was wrong. I don't know. All right. So wait a minute. Now I have to split my screen. Okay.
Okay.
Just a second. I don't know why I can't. This thing worked. This is.
At the bottom of the screen, you will find a button for share. If you can share your presentation.
In French, I have that, but it doesn't change anything. I only see this. Wait a minute. Just a second. Do you see it?
Yeah, it's okay now. We are able to hear you and see you both.
But do you see my screen?
Yeah. Yes. I can see.
You have this first slide, yeah?
No. So we don't see the slide, but we see only you.
No, that doesn't work. I'm not interesting.
Yeah.
I have to have my slide.
They'll get it.
So the screen doesn't work.
Yeah. Coming.
Yes, it's appearing now.
Getting now.
No, you cannot see my screen. I cannot do this share.
Just now we could you got a message that we are seeing your screen.
Do you see my screen? I don't think you see it.
Not yet.
No.
Oh, here it is. That's better.
Yeah, got
Yes, it is seen now.
You see it now?
Yes.
Yes.
So you see it, okay?
Yeah.
All right. Good. You get there. Okay. I'm very happy to be today with you on this special day of the Institute Foundation Day of the Homi Bhabha National Institute. And it is very interesting. I followed what was going on, and it was very interesting to see all these young people getting their awards. Congratulations to them. Another thing I would like to add is that at the beginning, you were standing up in honor of the late Chancellor, Professor Srikumar Banerjee. I was standing up also for another reason. Because on the 23rd of March this year, the day Professor Banerjee passed away, my wife also passed away. She was a theoretical physicist, which is something quite linked to your institute. And as a consequence, I would like to dedicate this day's lecture to Professor Banerjee and also to my spouse for 55 years. Thank you. So my lecture will do with a general approach. Just it will be a general lecture because the people listening, the students listening are from very different origins, different expertise, different fields of activity and research. So I have chosen a very general title, which is Steps Towards Life Chemistry, trying to show that chemistry is really underlying the steps towards life.
To interview, sir, could you go full screen in the presentation? Then we can see the full presentation.
Sorry?
Can you go full screen so that we can see the presentation on the full
screen.
Yes.
I am full screen. I am full screen.
Okay, go ahead.
Do you see it or not?
We see the screen, but we see also all the slides on the left side. So you may have to.
No, I
in
have.
Your slideshow.
No, I have my slideshow is not here. I have. No, you don't see. You do not see this, the real screen. What you see is not correct. The middle. This is not the full screen, and now it's the full screen. Do you see it? Yes or no? What do you see?
Not yet, but I think you can proceed with the lecture, sir. It's okay.
No, I
we can
cannot
see
proceed this way.
We can
This
see the
is no
slide.
good. I'm sorry, this is no good. So why do you not see the full screen?
I think in your slideshow at the bottom. No,
of course I have it.
You can press.
I have done that 100 times.
You can press the key F5, then it may become full screen. F5.
What do you see right now?
No, we don't see the full
slide.
screen.
No problem.
Now tell me what you see, please.
We see the slide, but not on the full screen.
This is not possible. I have full screen here.
So there's some glitch. Okay. Maybe we can proceed like this because we are able to see the screen.
I do not want to proceed like this because it's no good. This is not what I want. It cannot work this way because I have a lot of automations, a lot of animations.
Sir, then you need to share the presentation.
That's what I did.
No, you have to share the application, not your screen. You have to share the application, which is PowerPoint. Then you will be able to do everything like you do usually in PowerPoint.
Now I have stopped it. Okay. Now I have stopped the sharing. I will come back now to the sharing.
Yes.
Okay.
Yes.
Please.
When you click share, you will get several options. You click application as the option and choose PowerPoint. Since you opened your presentation, you can see that there, and you can share that. Afterwards, everything will be fine.
No, nothing is working right now. There's no sharing. It's blocked.
Just hold for a moment. There may be a network issue. Just hold for a moment.
Why do you use something else than Zoom? Zoom works.
Unfortunately, Zoom is not permitted in the government organizations.
We have security issues with Zoom.
Yes. And we have been using WebEx for last 1 year, and we offer all our webinars, and we usually do not find a problem. Sometimes there's network issue, and that could be the issue here.
I don't know, but my screen is blocked.
Okay.
I cannot get out of the share. I cannot get into the share.
Now, just hold for a moment. We will resolve it for you. Please hold on.
Sure.
We are ahead of time, so we can know. Just 1 minute. I think you have the permission now to share. You can try again. Yes, it's coming up.
Yeah.
Yeah, but that is not the correct one. That is not what I want to see.
No, you are sharing your screen, not the application. You click share, and then
on what?
Share the application. Professor Len, if this doesn't work, the only other option is you could send the presentation by mail to us.
No, I
Play from here.
cannot. No, sorry, okay. I don't do that. I will not do that because it is not the way I operate. Either it works or I stop. This is not what I want to show you.
No, this is not. You are sharing this your window.
Yeah, I don't want to share the window, of course.
You minimize this browser. After you minimize the browser, if you share, you just shared some time ago, we were able to see the presentation.
Yes, but not on full screen, and it has to be on full screen.
Yes. On the same screen, if you are able to go to the play in the presentation mode and say go full screen, it should be possible. We are sorry that there's a technical issue, but we can wait for some more time.
Yeah, but this is not full screen. That's not what I can use. Now I try.
But at the bottom, yes.
Right. Press that. Yeah.
What do you see? Is it full screen or not?
Huh?
Is it full screen?
No, it is not yet full screen.
I cannot do anything else. That's all I can do.
Sir, we can skip the animations and proceed with the rest of the lecture if possible.
No, we cannot skip the animations. That's not possible.
Yes.
I'm sorry, but that is not possible.
On the top, on the slideshow, is there any option on the left side, on the top?
I know you don't see my full screen, huh?
Not yet. We don't see. We are seeing the screen with the presentation, first slide, but it is not full screen. The other slides are also seen on the left side.
And now I put full screen. Here I have full screen. Why don't you have it?
Whatever, can we switch off and come back again?
Is it, sir, are you using by chance Mac?
Oui, j'arrive pas à mettre le full screen. Il voit mon truc, mais pas full screen. Qu'est-ce que ce cirque? Ça m'est jamais arrivé. Oui, peut-être, oui, venez. Ah ben oui, il est devant mon écran. Il voit le truc qui n'est pas full screen, mais il voit le reste. Il voit le reste. I've asked somebody who is in charge here.
Who is going to try to help? Yeah.
This is the first time this happens.
Yes. For us also, this is the first time, but some things happen like this. We can wait for you.
Sure. I have nothing else to do anyway. What do you see right now?
Same.
You see something in the middle, and then on the left-hand side, you see the slides.
Yes. Yeah, the slides.
Yes. But it is not full screen.
It's not full screen.
So this
yet.
is not full.
Oui. Ça, il le voit, mais quand je pars sur écran, là, il ne voit pas. Vous pouvez faire arrêter le partage? Oui, j'avais fait ça auparavant. We will try to stop it and start again.
That's right. Okay.
Yes,
Let
sir.
it.
Vous avez couru là. Hein? Vous étiez où?
À ISIS 2.
À ISIS 2, oh le pauvre. Bon, alors maintenant, partager, oui, c'est ce que j'avais fait. OK.
Non.
Alors, il faut mettre application.
Oui.
C'est ce que j'ai fait. Voilà. Alors, oui, c'était ça, oui, c'est ce que j'ai fait. Et maintenant, je fais full screen.
Okay.
Do you see full screen or not?
Not yet.
Not yet.
Alors, on fait autrement. On va arrêter.
We try something else.
Yeah.
Partager. Encore une fois.
Écran.
Vous jetez tout. Faites partager. Il faut le sélectionner.
Oui, mais là, c'est l'autre truc que je sélectionne. On va voir.
Partager. Voilà. PowerPoint.
Où ça? Ah, celui-là.
Voilà. Full screen.
Do you see?
Voila. Yes, we are getting it.
Là, vous partagez tout.
Yes.
Donc, il voit exactement ce que vous avez dans
Oui. OK.
We got it.
You know, this is WebEx is not good. It's no good. Zoom is much better. Here you have to have 3 or 4 other things to do before it comes. Okay. So let's take our time. All right. So as I said, it will be a general lecture which has to do with chemistry underlying the steps towards life. And for that, we have to start very early on with the Big Bang, which started our universe. But at that time, there was no chemistry. It was much too hot. This was the age of physics. Then it cooled down quickly. Particles formed aggregates. nuclei, atoms, and so on. And then when atoms began to unite to form molecules, chemistry started around here. It's the age of chemistry. The molecules generated by recombination of the atoms then progressively became more and more complex. They find compartments, and out of this, by some mechanism we don't know yet, but we will of course understand, because life is a chemical process, then something new, this property called life, emerged from the very complex chemistry which had formed in the universe. And around here, life started on our planet Earth, the age of biology on our planet. But evolution continued and generated another property, which was even, I would call it, more important for us than life itself. But of course, one cannot come without the other, and that is thought. And that is the evolution towards more and more complex forms of matter on our planet. I want just to point out here that we are just a point in space and in time, nothing else. There are many other planets. There's very probably biology, life, and thinking on other planets too. And the end of the screen is not the end of the evolution of the universe. There are people around the world who want to stop, who said, oh, it's good enough now. This is not possible. The universe will continue to evolve, not worrying about these organisms sitting on a very small piece of dust in the immensity of the universe. But we will see later that mankind has been able to look deeply into this. So our universe is still formed of darkness. 68% of dark energy, 27% of dark matter. That means 95% of darkness. But there's 5% of visible matter. And this is the matter that matters for us. We are part of this 5%. Now, this evolution with time of matter in our universe had to do with an increase a long time in complexity and in information from divided matter to condensed, to organized, to living, to thinking, and maybe to something even more complex. But this we don't know, of course. We don't know right now. Thinking beyond our own way of thinking is something which we cannot do. But this is the evolution towards complex matter with perhaps in the future something else evolving. Now we have to ask then a very big question. The one I consider that probably the biggest question we should ask ourselves, which is how does matter become complex? How did it happen that the universe went from the elementary particle to a thinking organism? And maybe there are even higher forms of complex matter to be evolved. The answer to this question is what we are looking for, of course. And for that, mankind on our planet, in this small place in our universe, has created what we call science. And if you look at three pillars of science, at least two pillars plus a bridge, physics deals with the basic laws of the universe, those on which everything else depends, of course. Biology deals with the rules of life. How does it function? These are not laws. The laws are the laws of the universe. These are the rules by which biology organisms function on the basis of the general physical laws. And the role of chemistry is to build a bridge between the general laws and the specific expression of those laws in an organism like a human being on a planet called Earth in our enormous universe. So chemistry has a very important role to play. How can one translate a set of general laws into a specific expression in an organism like mankind, like a human being? And this is what I would consider as the very important question, because in order to understand our universe, we have to exist. That means the laws of the universe have to be translated into a thinking organism somewhere in the universe, like on the planet Earth. The answer to this question, how does it become complex, is by self-organization. I consider this as the driving force of our universe. In other words, I consider that the laws of our universe are such that the structure of our universe is such that it will become organized somewhere by itself on the basis of how it functions. So that I might call it a cosmic imperative. It is not an accident. For me, life is not an accident. Life is an imperative. Our universe has a structure such that somewhere, and probably, very probably in many places, there will be an organization, self-organization generating evolved, complex organisms like human beings on our planet. The self-organization, we have to look at it right now in two ways. On the large scale, cosmic self-organization, which generates cosmic structure through gravitational forces operating on inhomogeneities in density and rates of expansion at very early times, just after the Big Bang. This is what cosmologists tell us. All I can tell you is what I read. But for us, it's a self-organization of complex matter which is important. And this molecular matter is self-organized through electromagnetic forces which act on the bricks of matter, which we know are atoms, and they are combined, recombined, they change with time, they adapt, they modify themselves, and progressively, they are more and more complex forms of matter being formed by this self-organization process. So chemistry is this part of science, of the general panorama of science, which deals with the structure of matter and the transformation of matter, non-living matter as well as living matter. Structure is how it is built. Transformation is how can you transform matter, objects of material type into one another. This is why I am a chemist, because I felt when I was a teenager, a bit longer when I started university, that the power of chemistry is to transform matter, to transform the intimate structure of matter from one entity to another one. We'll come back to that. Now, over the years, scientists were trying to find out what were the bricks of matter. And along times, they found that there were bricks which which formed matter around us. But it was rather chaotic, but didn't know how to organize that until the middle of the 19th century, when several proposals were made, and the most successful, the closest one to what was the correct way, was proposed by a Russian chemist, Dmitry Mendeleev, in 1869. In 1869, he published a very famous paper, which you see here. That is the original publication in a German journal, in Zeitschrift für Chemie. The title in English is, translated into English, is On the Relationships Between Properties and Atomic Weight of the Elements. He had noticed that one can classify the elements according to their relationships, to their atomic weights and their relationships with the properties of the elements. And this came up, this then generated, he proposed a table which you see on this page. And you can see, for instance, here, you have beryllium, boron, carbon, nitrogen, oxygen, fluorine. This is vertical, now it's horizontal, but it's the same. And so this table is the original table proposed by Mendeleev in 1869. He had even put question marks in this table, indicating that this wasn't known yet, but he was convinced that it will be found, and indeed, the elements which were not known at that time were found in the future. This is now what we call the periodic table of the elements. And right now, we all know, or we should at least know, I'm sure everybody listening to my talk will know that this is now the periodic table of elements, and these are the bricks of our visible matter. Let me insist, of course, this seems to be trivial, but it is not at all. One has really to think deeply about what this represents, not just what is obvious, what we have seen in all classrooms, in all books, and so on, but what you have before, in front of your eyes, is the bricks which compose visible matter in any place in our universe. Do you realize what that means? That means mankind has been able to generate a table in which are located, shown, organized, all the elements, all the bricks which make visible matter in our universe. Gallium is the same on the planet Earth as at the end of the universe. Boron is the same. Platinum is the same. Carbon is the same. So can you imagine, or you must be able to imagine, that mankind, thanks to science, has been able to produce a table which tells us what everything, part of visible matter, is composed of, any place in our universe, from our small planet Earth to the ends, if I may say so, but to very far away, billions of light years away from our planet. This is a fantastic achievement, of course, of science, and this is the playground of chemistry. Chemists play with these elements, with these bricks, connect them, recompose them, and so on. Now, going from the atom to collections of atoms, connected atoms, molecules, led to the birth and to the development of molecular chemistry. Molecular chemistry deals with the architectures made from these elements connected together by strong bonds, which we call, as chemists, covalent bonds. And these then are a very large number of these have been found, have been organized. And let me just give you two milestones in the development of molecular chemistry along the times. The first milestone I would like to mention is the formation, the production in the laboratory of urea by Friedrich Wöhler. He made urea in the laboratory from another chemical, which is called ammonium cyanate. Now, urea is contained in a living organism, in urine. Ammonium cyanate is not. Ammonium cyanate is part, let's say, of the non-living world. So, at that time, I was thinking that one could not make in the laboratory anything contained in an organism without the help of a magical force, the vital force. Wöhler, by producing in his laboratory, transforming in his laboratory ammonium cyanide into urea, showed that that is possible, and therefore the magic force, the vital force, did not exist, and that chemistry is chemistry, molecules are molecules, and be they living matter or non-living matter, it's all the same. Now, 150 years later, this much more complicated year, a molecule, vitamin B12, was made in the laboratory, in the two laboratories which were collaborating at that time. The one directed at Harvard University by Robert Burns Woodward, which you see here on the left, and the other one at the ETH, the Polytechnical School in Zurich in Switzerland, by Albert Eschenmoser. They were directing two groups, united their efforts, and this altogether was an enterprise which took many years, at least 10 years, but many, many co-workers who all contributed to the progressive setting up, the progressive building up of this very complex vitamin B12 molecule from its elements, carbon, hydrogen, oxygen, nitrogen, phosphorus, and so on. So this was a highlight, this was a high step of organic synthesis. And organic molecular chemistry continued to evolve and continued to invent new procedures, new reactions, make new molecules, new materials, new drugs, and so on. and it will continue for many, many, many years. Organic chemistry is an adult, very strong and very well-based science, which we still have, of course, a very, very wide future. But then we can ask the question, is there something we should think about, which is maybe beyond the molecule? I can introduce that in the following way. Here you see a cancer cell, the blue sphere, and 2 killer cells. These pink, violet type purple things, these cells. The killer cells have as mission to find the cancer cells and to destroy them. But of course, they should not make a mistake. They should not destroy a healthy cell, but they must destroy the cancer cell. How do they know that the other one is a cancer cell? Here, you see blue dots. This is the HIV virus, which when it hits a white blood cell, can penetrate, can infect. How does the virus, so to say, know that it has reached its target? What happens? So there must be something happening between the molecules which constitute these entities, these cells, these virus particles, when they get together. Something must happen which tells one of them what the partner is. That means that something is happening between the molecules which constitute these entities, these large entities, compared to a molecule, of course. And that is a chemistry which is beyond molecular chemistry, which we have called supramolecular chemistry. It's a chemistry which deals with what happens when molecules get together, when they attach to each other, they, so to say, speak or talk or touch each other. And this is then a chemistry which deals with the interactions which occur between molecules, not the ones which build up molecules from the connection of atoms, but which, beyond this, deal with populations of molecules, interactions between molecules, and trying to understand how these interactions occur and what they do. The 3 main properties which are studied over the years in this field of supramolecular chemistry is, first of all, molecular recognition, which is, of course, the basic property which deals with how molecules can recognize one another, how a cell can recognize a cell, which is entirely dependent on how the molecules forming the cells recognize or build or can recognize another molecules on another cell. Of course, also reactivity between molecules and transporting molecules between a barrier, artificial or natural. We come back briefly to that in a moment. Now, this molecular recognition is the most important process. It requires, obviously, interactions between molecules, because otherwise they ignore themselves. They cannot interact. They cannot know the other one is present if they don't bind. But very importantly, a third property, which is a basic property of chemistry and which was highlighted by and introduced by supramolecular chemistry's information. In order to recognize, you need information. That means molecules, they must contain information which makes it possible for them to recognize one another. This idea was already around for many years, and one may say in a very simplified way that it rests this information on the double complementarity in geometry between the objects getting together and their interactions. And already at the end of the 19th century, a German chemist, Emil Fischer, proposed in one of his papers, a very famous paper written in 1894, on the interaction, on the action of an enzyme on its substrate, that they have to fit together like Schloss und Schlüssel, like a lock and a key. And this is a very basic fundamental process in, of course, biology, because without molecular recognition, you have no life. Life cannot exist without molecular recognition. You cannot exist, you cannot function without molecules knowing exactly what to do, when to do, at which place in a cell, and so on and so on. Emil Fischer got his doctorate in 1874 in our university. And we are very proud of that, of course, because this is, let's say, probably the most basic property at the start of life. And not just of life, also of non-living matter, of course. Now, let me illustrate just a very obvious thing, but again, thinking about it is important. Molecular storage of information has been expressed in its most important way for living organisms in the genome of living organisms. And this shows how molecular information can lead to very, very complex consequences. What is it based on? The molecular information forming the genome of all living organisms, and of course, the genome contained in this double helix of DNA, is based on a very long string, you see here on the left, of phosphate and sugars, ribose, deoxyribose, and just 4 chemical letters. These chemical letters are very simple molecules, for instance, compared to vitamin B12. Chemists have given them names: adenine A, guanine G, thymine T, cytosine C. And it's the sequence of these 4 letters along a very long chain, just sticking on this chain, that makes the difference between a tomato and an elephant, between a dog and a human being. So just 4 letters are enough to write the genome of all living organisms on our planet. Now, storing information is one thing, but you have then also to process it, to read it and process it. This happens also by a very simple process, just by pairing up these letters. Pairing adenine with thymine or uracil, just a variation, does happen by 2 points of interaction. Here, these little dots here, they represent interactions between this group on adenine and this oxygen here on thymine. And there's another one. So this is pairing by 2 points of interactions. And here, guanine and cytosine pair up by 3 points of interaction. So it's a binary system where the information can be read by 2 or 3 points of interaction. In other words, what forms the basis of storing information of the genome and processing it is a very simple system, just 4 letters and 2 ways of pairing. Why only that? Maybe evolution in its course has tried more letters, more ways of interaction, but probably it was so complicated that many errors were made. And so finally, what stood up against time, a long time, is the simplest 4 letters are enough to lead to 2 ways of pairing and therefore a binary system. And after all, you know, this is very similar to a computer. What's a computer doing? Current goes through, current is stopped. 1 0 1 0 1 0, 2 3 2 3. So very simple, but certainly the most complex program ever written, and when a living organism develops from the initial information stored in the DNA molecule. So chemistry can claim also to be an information science, not only, but of course proudly, the science of the structure and transformation of matter, but beyond also molecular storage of information and supramolecular processing information. That means chemistry is also not only the science of the structure and transformation of matter, but also the science of informed matter, of information in matter. Now, these ideas of molecular recognition were then very much studied in the last 50 years. And here I just illustrated by taking the lock and key idea of Emil Fischer. At that time, it was not called recognition and so on, but Fischer had the right idea that they have to fit together. Of course, we know that the locks are adaptable, that the keys also can adapt to some extent, but basically the locks and keys image of Fischer is basically the one which which we can sort of keep. Now, here we have just a picture with 3 different keys on the left-hand side, and a lock in the middle, a receptor, and as you see, of course, the red key fits. This type of processes, then very many laboratories have studied molecular recognition processes because they are the basis of what molecules do when they get together. If we have to look at what kind of information, what kind of application have been produced over the years, of course, one is always asked, sure, okay, supramolecular chemistry, but what is it good for? First of all, we have to insist on the fact for when we talk to anybody in the street or to our politicians, that first we need basic research. Without knowledge, we will have no applications. Applied research tries then to apply this knowledge gained through basic research. And let me just illustrate by 3 examples of our work, which deal with 3 different aspects of supramolecular chemistry I mentioned a moment ago. First of all, drug discovery is based on molecular recognition. What is a drug? A drug is a synthetic key directed towards a biological target, and which in principle should fit as selectively, as specifically to this biological target as possible, so as to not have side effects and only act on the target. So for drug discovery and for understanding basic life processes, molecular recognition is, of course, absolutely mandatory. Then we had also developed along the years some other things, like, for instance, making molecules which have a hole inside. This I have no time to talk about, but we call them cryptates. And when you introduce a europium ion into this hole, you can make this complex molecule now fluorescent, has a red label, like a red label, which is used now for medical diagnostics. And right here you see an apparatus which is used in many hospitals now, which is built on labeling immunoproteins with this fluorescent label, and then developing diagnostics technologies on the basis of this connection between the label and the immunoprotein. Then also transport processes are important, of course, and I mentioned that bringing a substance into a cell is a way, it's the barrier of the cell, the membrane, is a very important process. It has become even more important. We studied it in more physical-chemical terms, but in biology, it's well known that the homeostasis of an organism is linked to the selective transport of special entities by special mechanisms of compounds in from the outside to the inside the cell, and especially because it's this type of transport processes are present in any organism. In addition, gene transfer has become more and more important. Gene transfer is transporting a synthetic vector. It's transporting a gene with the help of a synthetic vector inside a cell so that it may produce at the end of it the protein corresponding to the gene. This is of fundamental importance for gene therapy, which has been developed. In some cases, it's still being developed, and in biotechnology. I would also like here to insist on one thing, on the fact that biotechnology of gene transfer leads to genetically modified organisms, and I want to very strongly stress that genetically modified organisms, we need them, and if people are afraid of them, too bad for them, because they will stay. Nobody can remove this, and this knowledge will stay, and we will use gene transfer for generating, for instance, plants which are necessary for feeding humanity in conditions which are not necessarily ideal, where in drought conditions, in very high temperatures, the conditions, and so on. Then finally, there is also an aspect to it, which is the aspect of supramolecular materials. And I will just give you one example because it illustrates well the passage from acquiring knowledge to applying knowledge. we had published in 1990 a paper which introduced the field of supramolecular polymers as polymers of a new type, which were based on interactions between molecules and not linkage of monomers through covalent bonds. This was in 1990. In 2013, I got an email from a small company which had developed biocompatible supramolecular polymers and which were made to be used for reconstructing the heart of children who had severe congenital malformation. That means making cardiovascular implants for children. This, of course, was a long way ahead of the initial proposal, but it was on the basis of supramolecular polymers. And here is the first little girl who in 2013 is shown here 3 months after implantation at the Bakulev Center for Cardiovascular Surgery in Moscow by the surgeon here, Professor Leo Bokeria. They both seem very happy, and now many children have been successfully implanted and had their heart reconstructed. I write here 10, but there are many more than 10 now. And there's another development then. The same company made also heart valves, which have been implanted. This again is not up to date in Budapest, in Krakow, and Kuala Lumpur. What I want to stress here is just that from the basic research of making supramolecular polymers to the application, and especially to the introduction into a human body, there is a long way to go. It took 23 years. And of course, much of this is due to the fact that it has to be introduced in a human body. But it happened. And therefore, this is a good way to show also to those who don't believe in knowledge, in science, and so on, that basic science, basic knowledge is absolutely necessary for having new applications. But it can take a long time, and we have to be patient and work hard on it. Now, another property of supramolecular polymers is that they are self-healing. Self-healing meaning that when they break, but they can restore the breaking points. And here we can see that this film can be cut into pieces. Sorry?
You can proceed.
Okay. This film can be, you see the film here. It is cut in 2 pieces with scissors. These fingers which you see are those of one of my Indian postdocs who was in my laboratory at that time. You cleave it in 2. You superpose the 2 pieces here, and then you press with your finger in this position, and you get a film which sticks and you can stretch again. So that is spontaneous healing, self-healing of a supramolecular polymer film. Of course, it has, in principle, many potential applications. Now, let's go back to the main line, which is, of course, getting more and more complex states. We have been molecular chemistry, we have seen supramolecular chemistry and applications of it. What about now the step, this self-organization, which is the driving force of our universe? For me, self-organization is a driving force of the universe. So, self-organization, if you want to practice it in a laboratory, it means that you would like to generate large architectures, supramolecular architectures, in a spontaneous way, but based on molecular recognition patterns. That means controlled by molecular information. One way to illustrate that is simply to take a virus. We all know that there's now a virus running around the world, which is not very good for us. But viruses don't live. It's just a piece. It's just a bunch of molecules sitting together. And let's have just a look at this tobacco mosaic virus, which was the first one to be well understood. This is a sort of a tube made from 2,130 protein subunits, which get together by surface-to-surface contact. These surface-to-surface contact are on the basis of recognition between these protein subunits. and they automatically, just binding together, generate, as you see on the left-hand side, this piece of a pie, which then gets together and eventually generates this helix. And this is something which is not magic. It looks like magic. It's not that magic. We can understand everything there. It's organic chemistry, structural chemistry, physical chemistry, let's say information science if you want, because there's information in the molecules and so on. So this clearly shows that matter can self-organize even before life existed, because a virus, as I said, is not living. A virus can only, when it penetrates a cell, uses part of the machinery of a cell to reproduce itself. So in the laboratory, it has been in the 90s or so, people have started to try to understand better and better how one can do some things like that in the laboratory using pieces which might recognize one another and generate a complex architecture. This is then a sort of a programmed chemical system, and we can think of having a molecular program stored in pieces, entities, components, molecular components, and then having the interaction between these molecules performing a supramolecular operation so as to process the information in question and generate the final output. I want to illustrate that very simply by one of the simple cases, and I will only organize it, show it simply. The bricks will be organic molecules capable of binding a metal ion, and the metal ions will be the connectors, the cementing units which link these organic molecules together. On this basis, I just show you some examples. The examples I show you are all work we have been doing in my lab. This is the artificial double helix. That's an artificial triple helix. They have nothing to do with a natural one. It's just a planning, it's just a design of molecules which are linked together by metal ions. On the left-hand side in the double helix, you do not see the metal ion, but here on the right-hand side, you see it. This yellow spot you can see here, you can just see between the strands is shown is a metal ion. In this case, it's a nickel ion. And you just mix the molecules with the metal ion and you get automatically the double helix, automatically the triple helix. Also, if you take these units here, which are flat molecules, they are seen on the side. They have 3 points of interactions, metal ions. 3 times 3 is 9. So 3 horizontal, 3 vertical molecules get together, linked together by 9 metal ions. Even better, in some, as you may say, there are here linear molecules in red, flat molecules, planar molecules in blue, linked together by altogether 12 metal ions. And this again happens, these 19 components, 3 plus 4 plus 12, these 19 components get together spontaneously, but in a very organized fashion to generate this kind of thing you may call a nanocylinder. These are some others just to show nice that there are big things larger than the other ones. And of course, many people, many laboratories have done fantastic contributions to this design of more and more complex self-organizing structures produced from the molecules and the way, the specific way in which you can bring them together, link them together through metal ions of the correct coordination, geometry. Now, this is also of interest for nanoscience and nanotechnology because you can tell yourself that, in fact, rather than having to fabricate a device, maybe we can in the future build the pieces and let the pieces assemble spontaneously into a device. Of course, this is for the, self-organization it's quite obvious that it can contribute to it. And beyond than what we now do, which is fabrication and manipulation, one can hope that someday we will go from the need to fabricate, to the object making itself by self-fabrication. In fact, I can easily convince you of that. We have a brain. The brain handles all our information. The brain is self-organized. It makes itself on the basis of what it is built on. So it exists, therefore it's possible. That's a tautology, but that is what is the case. The brain is the most complex computer around, and it makes itself in a very, very, very complex set of developmental steps, of course, which we still have to understand. And this would be the ultimate fabrication. So at this stage, I want just to very quickly go over. What I have shown you is I have stressed the fact that chemistry is an information science, which you can program, where you can design information into the objects and introduce a program on the interaction on the supramolecular level, and then in this way, in a controlled fashion, generate functional molecular and supramolecular entities. Now there is a step beyond that, because we have to think about more complex things than the design itself, where everything is introduced as such from the start. This is going beyond it through selection. Selection is another property which can be introduced if the system is able, from a diversity of building blocks, to select those which are necessary for constituting the final object. The system should also be dynamic, meaning that if a first collision between two objects is too strong, then it cannot explore the thermodynamic hypersurface, which would lead to maybe a better combination. So the system has to be dynamic, so the objects which form can dissociate, reassociate, so as to explore the hypersurface and find the best situation, which means thermodynamically the best situation in this equilibrium thermodynamics state. So we are then working, we have developed that. We have been working now for about 15 years, maybe now, okay, more close to 20, on what we call constitutional dynamic chemistry. I mean by that, it's a chemistry where the chemical object is dynamic in its constitution. It can fall apart, reassemble, and maybe in the reassembling process, if it is submitted to a given agent, it may be different. So it may adapt, and it leads to what we now mostly do is adaptive chemistry. Adaptive chemistry is a chemistry where the lability, the fact that objects can dissociate into pieces and reassociate, makes possible responding to agents which can be agents in the medium. It can be pressure, it can be heat, it can be chemicals added, it can be metal ions, it can be a change in solvent, and so on. Let me just, since we were a bit in advance, but now maybe another advance, but let me just show you very quickly an example, because I introduced it, so I want to show it quickly. So this constitutional dynamic chemistry makes possible, as I said, adaptation by responding to agents, and it has been used for developing new ways of searching for biologically active substances, for making dynamic nanostructures, and also dynamic materials. These materials are self-healing, responsive, and adaptive. So this has all been developed. I have no time to talk about, but I want just to illustrate it by one example. And even if you haven't time to go into the details, it nevertheless shows you what is possible. That is what I want to show. Let's look at the systems which are dynamic, but which reveal this dynamicity by an optical feature, a color or a fluorescence. Suppose you have two polymeric films, one constituted of AB and the other one of A prime, B prime, two elements, two monomers. And the connection between A and B, like between A prime and B prime, are dynamic. That means they can break and reform. If you superimpose these two films by a corner, for instance, in this place, if A and B can break apart and A prime and B prime can break apart, they can recombine in a different way by generating the two combinations which did not exist beforehand. A can combine with B prime and A prime can combine with B. If one of these two known combinations these two new combinations has a color or a fluorescence, you will see it. And that will prove, of course, that a recombination has occurred. So my Japanese co-workers looked at made this nice picture here, a cat, the head of a cat. The head and the ear is polymer AB. The inside of the ears and the eyes and the mustache is A prime, B prime. And now you superimpose your heat so as to accelerate the reaction. And what do you see? Color and fluorescence, only where it is superimposed. That means that indeed, these AB and A prime, B prime initial constituents had broken up into their components A, B, A prime, B prime, and had recombined by generating the two constitutions which were not present at the beginning, AB prime and A prime B, and one of them had color and fluorescence. So that shows you, it illustrates what this adaptive chemistry is about, what this dynamic chemistry is about. I have no time to go further because I want just to conclude now with some general considerations, but I hope that you have seen what power can be residing in these dynamic aspects of chemical objects. So chemistry has evolved from molecular to supramolecular, to organized, dynamic, adaptive, and steps progressively going to higher states of complex matter. Now, I suppose also that you have realized that the essence of chemistry is not just to discover, but also to create novel expressions of complex matter. In other words, the book of chemistry has to be written, not only to be read. Of course, we have all to read the book of chemistry which already exists, the book of the chemistry which is around us, the book of the chemistry which is inside us. But there are many things which haven't been made by the recombination of these bricks of matter, of visible matter, which we find in the periodic table, I stressed at the beginning. Similarly, the score of chemistry, like music, has to be composed before it can be played. But of course, playing it is one thing, but somebody has to compose it. So that's the same idea, that chemistry has creative power. Chemistry can create new objects which did not exist before. And this can be expressed again by a sculpture which you have already seen on the first slide. At the end of the slide, you had this statue, this sculpture by Auguste Rodin, the thinker, and this is now another one, where the hand of the artist expresses out of the stone a sculpture which is not contained in the stone. A stone is a stone. A stone doesn't do anything, but the hand of the artist expresses out of it this specific object which it wants to create. And this means that one can consider chemistry as the art of nature, expressing out of the possibilities offered by the multitude, the many elements, these combinations which reside in our imagination, in the power of chemistry and science in general. This has already been seen many years ago. I want just to illustrate that the idea in itself is something which probably mankind has always been thinking about, but not so well formulated. But Leonardo da Vinci, you know him very well, because of the Gioconda, the very, very famous painting you'll find in the Louvre. It was his 500th anniversary of his death in 2019. And he wrote a sentence which is extremely strong and which is very much looking forward into the future from his time. He writes, where nature finishes, this is in Italian on top, in English, where nature finishes to produce its own species. We are part of that. We are one of the species nature has produced. Man begins using natural things. What are natural things? Natural things are the bricks of the periodic table of elements in harmony with its very nature. What is in harmony with the nature? That's in accordance to the basic physical laws of our universe. So having set the stage, the objects, the bricks, and the laws which control the way they can assemble, the ending is extremely strong, especially for somebody who was an artist, a scientist, and an engineer. The ending is to create an infinity of species. So Leonardo da Vinci, looking very, very far and with a very strong statement, imagined that mankind will be able to just make from scratch by reassembling objects, elements, maybe even paints. In his case, a painter, you can, by using paints, make all kinds, an infinity of number of pictures to create an infinity of species. This is a very strong statement, which I like very much because it really shows the power of chemistry and, of course, of science. Now, in the Greek mythology, you know, Greece is a country in Europe, a rather small country in Europe, but which has a very long history. They have a mythology, like India also has a mythology, a complicated one, I must say. Many times by visiting India, I was, of course, interested in it. Now, in the Greek mythology, you have the gods, and you have Prometheus, who steals from the gods the fire of knowledge. You see he running away and looking over his shoulders to see if the other ones are not running after him to catch him, because he wants to give this fire of knowledge to mankind. He brings it to mankind, and the others didn't catch him, and here he is holding it high, very proudly. So he gave knowledge, the fire of knowledge, to mankind. But what is the consequence? That is, we cannot give it back. This is something we have to think about. Anything we know, and we cannot give it back. We have to live with it. But it gives us the power of knowledge. That means that we could say that our path through knowledge, through the quest of knowledge, will make possible to control our own destiny. We can now do things which is not natural evolution, but we can we can produce evolution ourselves. And I'm sure in the future, this will be done. Of course, we have to be very careful, but I'm convinced it will be done. So in the past, since we talk about universities, information was transferred, education was transferred from this more ape-like hand, fingers to the finger of a human being. Then in the present, it's human being to human being, transferring information, educating. What will be in the future? Maybe so. Now, I don't know, I don't want to say by that we will only shaking hands with robots. That's not the point. The point is simply to say that we will modify ourselves. And for instance, even nowadays, there are cases when somebody has lost the hand or the arm and has a prosthesis. When you shake hands with that person, you shake hands with another hand, a hand which is not a natural hand. So we have already changed ourselves. We may have a new lens in our eyes. We may have new teeth implanted. We may have some piece of titanium in our hip. These are all modifications. We are not the same anymore. We are modifying ourselves, and we already do it. Let's take even what might be considered right now as a sort of an ultimate stage at the present step in history. If you get a heart transplant, if I get a heart transplant, if you get a heart transplant, you cannot say to your companion, to your spouse, I give you my heart. It is not yours. You have the heart of somebody else. It's just a pump. But that's something we can do, and we have to be prepared for the fact that we will modify ourselves. Let me just finish with some mathematics. I haven't said much about mathematics, of course. This is a very famous mathematician, David Hilbert. a German mathematician who is buried here. You see David Hilbert. He's buried in Göttingen, a small university city in Germany. And there are two sentences written here on his tombstone, sentences he pronounced in one of his lectures. And I don't know, but maybe he wanted to have them here. What are they saying? First of all, the top one, wir müssen wissen, we must know. That's already something very strong. That is what drives scientists. We must know. That is why we do science. But then there's a confidence we must have in that. We werden wissen, we will know. That is what makes us confident that what we are doing will lead us to knowing, to more knowledge, to better control, to better knowing what we are doing here. Here again, science is showing the way. Science is holding the fire of knowledge, and which will make us possible to know, which make it possible for us to know. And for all those engaged into scientific work, and for those who are not engaged, it's true as well. Science shapes the future of humanity. Participate. For those who are professional scientists, it's obvious. For those who are just looking for their future, it is something they have to consider strongly. And for everybody, it is our future. Another aspect of science I would like just to stress is that science has no borders. Science has no dogmas, no religion, no politics. Science is the same for everybody. Science has no borders. It is a human activity which brings everybody together. More science will certainly help mankind in thinking over the borders, across the borders, and bringing people together towards the same goal. So I would like to thank you very much for having invited me for giving this lecture today. I would like also again to congratulate all those who have been awarded and all those who study science in general. And I would also like to ask them to make them conscious of the fact that bringing science to the whole population is very important. You have a mission as young scientists and older scientists, students and professionals, to spread science around in the population. And this will certainly help mankind very much. So have a good future. All my best wishes. Thank you.
Thank you very much, Professor Len, for your enlightening lecture. Your presentation makes us ponder about several important processes from the point of view of self-organization and supramolecular chemistry. These are indeed some valuable insights you've provided. At this point, if I may, sir, we wish to express heartfelt condolence for the passing away of your wife, and we really appreciate you speaking at our program this close to such a personal loss. I thank you once again for your lecture and your patience during the technical glitch.
Thank you very much.
Yes, sir. We've almost come to the end of today's function. I request Dr. B. Chandrasekhar, Registrar HBNI, to propose a vote of thanks.
Respected Professor John Mary Lane, Nobel Laureate, Chief Guest of today's event, Sri K.N. Vyas, Chairman, Council of Management, Secretary DAE, Professor Grover, Founding Director, Vice Chancellor HBNI, Professor Vasudev Rao, Vice Chancellor HBNI. I need to mention other eminent personalities, Professor Raj Chidambaram, Professor Anil Kakodkar, Professor R.K. Sinha, former Secretaries of DAE and Chairman to the Atomic Energy Commission. Professor Naik, Professor B.K. Datta, Institute Chair, Professor Professor Yahmi, directors, eminent scientists, deans and the CI, faculty members, members of the Academic Council, Planning Monitoring Board, Board of Studies, ladies and gentlemen. Once again, good evening to all. I feel great honor to propose vote of thanks on this important event of the university, the Foundation Day celebration. First and foremost, I would like to thank our chief guest, Nobel laureate and eminent scientist, Professor John Mary Lane, Chair of Chemistry of Complex Systems, Director Laboratory of Supramolecular Chemistry, University of Strasbourg, for having accepted our request and delivered JB Joshi Research Foundation Endowment Lecture. You truly have made full of knowledge today. Your deep and intellectual way of imparting knowledge on chemistry of complex systems and supramolecular particles have added glory to the day's event. We have no words to offer gratitude for your valuable dimensions on the subject. I am pretty sure the precious knowledge you gave us will definitely be of immense help to the students, faculty, and eminent scientists over here. I would like to express our gratefulness for presence of Professor Chidambaram, former Principal Scientific Advisor to the Government of India, Professor Anil Kakodkar, Anke Sinha, by making their gracious presence today. I wish to express my heartfelt thanks to the Chairman, Council of Management, Sri K.N. Vyas, for presiding on this occasion. Your words have inspired us and to the entire DAE fraternity across. Permit me to mention deep appreciation of Professor Joshi, J.B. Joshi, Emeritus Professor HBNI, for having introduced today's chief guest, speaker, and Nobel laureate to DAE fraternity. I'm sure this will go a long way. Special mention to Professor B.K. Datta, Institute Chair, Professor Chairman of HBNI Awards Committee, who has taken full effort and get the important step completed in a timely manner in the selection of the awardees with the support of Board of Studies. We extend our sincere thanks to all directors of CI, OCC, deans, conveners of BOS, faculty members of HBNI, nodal officers, and entire HBNI fraternity for having been part of this endeavor. We remain deeply indebted to Professor Grover, Founding Director, Vice Chancellor, for his untiring inputs to HBNI at all times. We are greatly indebted to you. It's very important to thank all members of our institute. Their combined efforts bear fruit, otherwise it wouldn't be possible. They show a strong unity and high spirit in making this event possible, though we have been online and offline all the times. I offer my gratitude to the entire audience who have remained connected with us to listen to the Nobel laureate lecture. We express our gratefulness to the student fellows who have received outstanding student awards and willingly remain connected throughout from various geographies. My thanks to Karunyu also for keeping us connected through beautiful words amongst the speaker. Once again, we thank you all for being with us this evening. It's a great pleasure. Thank you very much.
Thank you very much, sir. This concludes today's event. On behalf of HBNI, I once again congratulate all the awardees and thank everyone for attending this program and rendering it a great success. The medals and certificates will be sent to the awardees shortly. Let us now rise up for the national anthem and conclude today's program. Thank you.
Thank you, Professor Len, and thanks to all the we close the meeting here. Thank you very much.